Okay, let's see how to solve the problems in self exercise 6.9. And in order to solve these problems, we need the double angle formulas. Okay, let's recall the double angle formulas that we already learned earlier. Okay, now let's look at question number 1. Without using a calculator, determine the value of each of the following. Section A, 2 sine 30 cos 30. 2 sine 30 cos 30 is equals to sine 2 times 30, which is equals to sine 60, and sine 60 is basically square root of 3 over 2. Okay, question B, cos square under 65 minus sine square under 65 is equals to, so here we need to use formula number 2a. So in this case the value of a is 165. So this is a. Okay, so cos 2 times a, which is 165, is actually equals to cos 330. Okay, 330 is actually in the fourth quadrant. In the fourth quadrant, cos is positive. Okay, so the answer for cos 330 is going to be positive cos, and the equivalent reference angle for 330 degrees is actually 30 degrees. And the final answer, square root of 3 over 2. Okay, let's look at question C. 1 minus tangent square under 75 degrees over 2 tangent 75 degrees, and 75 degrees is actually angle A. And in order to solve this problem, we need to use formula number 3. Okay, and it's equals to tangent to A, and the value of A is actually 75 degrees. And when we simplify this, we will get tangent 150 degrees, and 150 degrees is in the second quadrant. In the second quadrant, tangent brings a negative value, so I put a negative tangent, and the equivalent reference angle for 150 is actually 30 degrees. So how much is tangent 30? 1 over square root of 3, and don't forget the negative sign. Okay, now let's look at question number 2. Prove that cosecant 2a equals to 1 over 2 secant a cosecant a. So let's recall the double angle formulas. And first thing, we look at the complicated part. It's actually located on the right hand side of the equation. So I'm going to take the right hand side, which is 1 over 2 secant a cosecant a, and it's actually equivalent to 1 over 2 secant is basically 1 over cos, so secant a is equals to 1 over cos a, and cosecant is 1 over sine. So cosecant a can be written as 1 over sine a, and if you simplify this, you'll get 1 over 2 sine a cos a, And if you refer to the first double angle formula, 2 sine A cos A is actually equivalent to sine 2A. So therefore we will get 1 over sine 2A, and 1 over sine is basically cosecant, and finally we get cosecant 2A. And once again, let's recall the double angle formulas. Let's look at question A. So the complicated section is on the left hand side. So I take sine 2 theta tangent theta plus cotangent theta. Okay. Sine 2 theta is basically 2 sine theta cos theta, and then tangent can be expressed as sine theta over cos theta, sine theta over cos theta, plus cotangent can be expressed as cos theta over sine theta, 2 sine theta cos theta. Okay, if you expand this section, you will get sine square theta plus cos square theta over sine theta cos theta. And here we can cancel the sine theta cos theta from this expression, and finally, by using the basic identity that you learned earlier, which is sine square A plus cos square A equals to 1, you can substitute sine square theta plus cos square theta with 1. Okay, so 2 times 1, and the final answer is actually 2. So we managed to prove that the left hand side is actually equals to the right hand side. Okay, now let's look at question B. And the complicated part is located on the left hand side. So let's take sine 4x plus sine 2x over cos 4x plus cos 2x plus 1. Sine 4x can be written as 2 sine 2x cos 2x plus sine 2x, and cos 4x can be written as 2 cos square 2x minus 1. Okay, the reason why I use formula number 2 option B is I want to eliminate this 1 from the denominator. Okay, so in order to eliminate the plus 1, you need a minus 1 at the denominator. Okay, plus cos 2x plus 1. Okay, and we can factorize the sine 2x from the numerator, and as a result we will get sine 2x 2 cos 2x plus 1, and at the denominator we will get 2 cos square 2x plus cos 2x. Okay, so let's factorize the cos 2x. Sine 2x 2 cos 2x plus 1 divided by cos 2x bracket 2 cos 2x plus 1, close the bracket. Okay, so we can cancel the cos 2x plus 1 from both numerator and denominator, and finally sin 2x divided by cos 2x will give you tangent 2x. Okay, let's look at question number 3c. So we start with the left hand side of the identity. Cosecant 2a plus cotangent 2a. So cosecant can be written as 1 over sine. So here we get 1 over sine 2a, and cotangent can be expressed as cos 2a divided by sine 2a. Okay, so the denominator is actually common for both part of the fraction, so we can make this as 1 plus cos 2a over sine 2a. Okay, and if you look very carefully, the second formula in the double angle, okay, if you look very carefully, okay, formula number 2, option B, which is the one here, if you transfer the minus 1 to the left hand side, you get cos 2a plus 1, and cos 2a plus 1 is going to be equals with 2 cos square a. So I'm going to replace this with 2 cos square a equals to 1 plus cos 2a. So 2 cos 2a divided by sine 2a can be expressed as 2 sine a cos a. So we can cancel the cos on both numerator and denominator, and same goes with the 2. And finally we'll get cos a over sine a, and cos over sine is actually cotangent. Now let's look at question D. The right hand side, which is cotangent x plus tangent x over cotangent x minus tangent x, and I am going to express this as cos x over sine x to represent the cotangent x, and tangent x can be represented with sine x over cos x, and the whole thing divided by, okay, again we have a cotangent x, so I'm going to replace it with cos x over sine x minus tangent x is replaced with sine x over cos x. Okay, and if you simplify this, you'll get cos square x plus sine square x over sine x cos x divided by cos square x minus sine square x over sine x cos x. and we can cancel this sin x cos x, and cos square x plus sin square x is equals to 1, and cos square x minus sin square x, okay, is equivalent to 2a. So we can replace it with cos 2x, okay, over cos 2x. So 1 over cos is basically secant. So, and finally we get secant 2x, and secant 2x is same as the left hand side. Given sin x equals to 4 over 5, where x is an acute angle, and sin y is equals to 5 over 13, where y is an obtuse angle. Okay, so obtuse angle is actually located in the second quadrant. Okay, x is actually located in the first quadrant. Let's draw a triangle to represent angle x. So this triangle is actually in the first quadrant, and x is here. This is the opposite side, and this one is hypotenuse, and this is adjacent. Okay, we know that sine is actually opposite over hypotenuse, so therefore opposite side is equivalent to 4 and the hypotenuse is equivalent to 5. So by using Pythagoras theorem we can get, okay, the adjacent side, which is equals to 3. So sin x equals to 4 over 5, cos x is adjacent over hypotenuse, so it's 3 over 5, and tangent x is equal to 4 over 3. So what is cosecant 2x? Cosecant 2x can be expressed as 1 over sine 2x, and 2x is actually 2 sine x cos x. Okay, so refer to formula number 1, and we know the value of sine x and cos x from the previous calculation. So sine x is 4 over 5, cos x is 3 over 5, and if you solve this using the calculator, 1 over 2, 4 over 5 multiply with 3 over 5. Okay. And the final answer is 25 over 24. Okay, next. For question B, we need to find the value of secant 2y. Let's construct a triangle to represent angle 2y. Okay, since the angle is in the second quadrant, so the triangle is going to be something like this. This is the location of angle y, okay, and alpha is actually the corresponding reference angle in the first quadrant. Okay, so this is the opposite side, hypotenuse here and adjacent is here. So the value of O is going to be 5 and hypotenuse is 13, and the value of A here is going to be 12, but since the triangle is in the second quadrant, the value of A must be negative 12. So for B, secant 2y is equals to 1 over cos 2y, okay, and it's equals to 1 over, okay, you have 3 options, okay, so you can choose any of these 3 options. So let's say I choose the first one, cos square y, minus sine square y, 1 over, okay, cos y. What is cos y? Cos y is basically negative 12 over 13, and sine y is equals to 5 over 13. So if I substitute negative 12 over 13 square, and then sine y square is actually 5 over 13, and we square this, and the value can be calculated using the calculator. And the final answer is 169 over 119. 169 over 119. Okay. And you can answer this question using the third option for formula number 2. If you do that, basically you don't require this triangle, okay, at all. So secant 2y is equals to 1 over cos 2y. So cos 2y can be replaced with 1 minus 2 sine square y. So it's 1 over 1 minus 2 times with 5 over 13 square. And let's find the answer using the calculator. (169 over 119).